So on today's video, what we're going to talk about reduction formula. So under reduction, the first thing that we're going to talk about the cast diagram, right? So I'm going to fill in the cast diagram. This is going to be 0 degrees. This is going to be 90 degrees here. And this is going to be 180 degrees, 70 degrees. And here it's going to be 360 degrees, right? So here, the first thing that I'm going to fill in is the 0. So here it's going to be just theta, positive theta. Then here it's going to be what? It's going to be 180 minus theta. Then here it's going to be 180 plus theta. And the last one is going to be what? It's going to be 360 minus theta. Or this can be also negative theta, right? Here can be also what? 360 plus theta. We now dealing with the 90. We can have 90 minus theta. This one can be 90 plus theta. Then what we're going to do is, we know the fact that this stands for A, which means sine, cos, and tan are all positive here. This one is S, meaning sine is positive only here. This is T, meaning only tan is positive here. And this is C, which means what? Cos is only positive here. To memorize it, just know the fact that all students take coffee, and this is called the cast diagram. So now let's look at the first example. The first example says tan, open bracket, 180 minus theta, close bracket, sine 360 plus theta, close bracket, and cos 180 plus theta. Then the last one is tan 360 minus theta. And we need to simplify this to its simplest ratio. So what we need to do is, we're going to look at each part of the trig ratio, and we're gonna look at the cast diagram to simplify this. Then we're gonna look at each part in the numerator and denominator. To make it simple for you guys to see everything, I'm gonna write everything here on the side. So we have the first one, says tan 180 degrees minus theta. We're gonna find where 180 is. So we look at the cast diagram and we see the fact that it's here, right? And what do we find? We find that only sine is positive. Since this is tan and only sine, meaning cos and tan is what? Is negative. So this one is going to be minus tan theta. And this will be the answer here. So you're going to say tan theta. Then now we're going to look at sine. So we're going to look at sine 360 degrees plus theta. So now we're going to look for where 360 plus is. So we see the fact that it's here. We see the fact that 360 plus quadrant says all trig ratios are positive. So the sign is going to be what? Positive. Because all of them are positive there. So this is going to be positive theta. So it's going to be sine theta. Here I forgot to write the minus. So this is going to be divided by the denominator, which is cos 180 plus theta. So we're going to find where 180 plus is, and we see 180 is here, and it says only 10 is positive. So if only 10 is positive, cos and sine are negative. So this one is going to be minus what? Cos theta. So this here is going to be negative cos theta. And the last one, which is going to be tan 360 degrees minus theta. 360 minus, let's find it where it is. It's here. Only what? Cos is positive, meaning tan and sine are negative. This one is going to be minus tan theta. So here I'm going to just say minus, inside a bracket it's going to be minus tan theta. So now let's simplify this. When we simplify this, it's going to be, we're going to multiply the numerator, denominator. A negative tan theta multiplied by sine theta is going to give us negative tan theta sine theta. Then the bottom part, a negative cos theta multiplied by negative, remember this is a negative, tan theta is going to give us what? Positive. So it's going to be cos theta multiplied by what? Tan theta. Look at this. We have 10 theta in the numerator and 10 theta in the denominator. So that is going to cancel out. So we're going to be left with negative sine theta divided by cos theta. Remember this. Remember the fact that we have an identity saying the fact that 10 theta is equals to sine theta divided by cos theta. So I'm going to use this identity. We're going to take out the negative outside. So it's going to be sine theta divided by cos theta. And that's going to be the same as negative 10 theta. And that will be your final answer. So now let's look at example number 2, right? Cos squared, open bracket, 360 plus theta plus cos 180 plus theta, then 10 360 minus theta, and the last one is sine 360 plus theta. We need to simplify this, right? First thing first, when we have something in squared, we need to change it like this. You're going to say cos, let me put a square bracket, and this is going to be 360 degrees plus theta, close bracket, and this is going to be all squared. This and this are exactly the same thing. Then let's rewrite everything the way it is. So now let's solve the individual. I'm going to do it here in red. So we know the fact that cos 360 plus theta, what's going to give us? We need to look for 360 plus. 360 plus is here. It says all trig ratios are positive. So this is the same as saying cos theta. So here we're going to say equals to cos square bracket cos theta all squared, right? We're going to take the second one with, so the second one is cos 180 plus theta. What's 180 plus theta? We see the fact that 180 plus theta is here. 180 says only 10 is positive, the rest is negative. So this is going to be what? Minus cos theta. So here it's going to be minus cos theta, right? And the next one is 10. I'm not going to write it on the side anymore. 10, we need to look at 360 minus theta. 360 minus theta is here. It says only cos is positive and the rest is negative. And since this one is what? Is 10. So this is going to be multiplied by, put it inside the bracket. So it's going to be minus 10 theta. And the last one is 360 plus, which is here. All of them are positive. So this one is going to be what? Multiplied by sine, what? Sine theta, right? Simplify this. This one is going to be the same as cos squared theta. If you take negative cos theta multiplied by 10 theta, a negative and negative is going to give you a positive. So this is going to be positive cos theta 10 theta, and the last one is sine theta, right? Let's change this into an identity. Leave this one the way it is. So it's going to be cos squared theta plus cos theta, and this one's going to change into an identity. So it's going to be sine theta divided by cos theta, close bracket, and this is going to be sine theta. The cos and the cos are going to cancel each other. So you're going to be left with cos squared theta plus what's remaining is sine theta and another sine theta. So this is the same as cos squared theta plus sine squared theta. Cos squared theta and sine squared theta is the same as 1. So your final answer here is positive 1. So now let's do this question where they say simplify this question without a use of a calculator, right? So what you're gonna do is you're gonna have to simplify each trig ratio to be into a special angle. Let me write down the special angles. You have 0, you have 30 degrees, you have 45 degrees, you have 60 degrees, you have 90 degrees, you have 180 degrees, and the last one you have 360 degrees. These are called special angles. So here we need to reduce each term to be a special angle. and we're gonna use those special angles to simplify the question, right? So the first one is cos 300. To change the 300, we need to change it into being 180 plus 180 minus, or 360 plus 360 minus, or 90 plus or 90 minus. So this one is closer to what? It's closer to 360. So if you say 360, right, minus 60, what do we get? We get 300. So this 300 can be replaced by this. So this can be the same as what? Cos 360 degrees minus 60 degrees. And look, 60 is what? Is a special angle. So let's replace that by that. Let's replace this by this. So you're going to say cos 360 degrees, what? Minus 60 degrees, right? Then the next one is 10. So we have 10, 150 degrees. 150 degrees. If you say 180 degrees minus 30, that equals to 150 degrees, right? So we're going to replace this 150 by this. So we get, this is going to be the same as 10, 180 degrees minus 30 degrees. And look at this, we have 30 here, and 30 is a special angle, and 180 meaning we can use the cast diagram. So this is going to change into 10, 180 degrees minus 30 degrees. Then the denominator is the same as saying sine 225 degrees, right? 225 is closer to 180. So if you say 180 degrees plus 45, what do you get? You get 225 degrees. So you're going to replace the 225 by this. So you're going to say what? You're going to say sine 180 degrees plus 45 degrees. And the last one is that cos 45, negative 45 is the same as saying what? Cos positive 45. So this one is not going to be changed because it's already a what? A special angle. So you're going to say this is equals to cos 45. Let's simplify this. So this is going to be equals to what? Look at the first one. We know the fact that the 60 is the same as theta. So you're going to find where there is 360 theta, 360 minus theta. And which one is the fourth quadrant? And only cos is positive. So this one is going to be positive. So it's going to be saying cos 60 degrees, right? Because this one we take it as theta. And the second one is 180 minus 30. We're going to look for 180 minus theta. 180 minus theta is here. Only sine is positive, meaning 10 and cos are negative. So this is going to be the same as negative 1030 degrees. And now let's look at the denominator. The denominator is sine 180 minus 180 plus 45. So we're going to look for 180 plus theta. Where's 180 plus theta? Is this one. 180 plus only 10 is positive, meaning sine and cos are negative. So this one is going to be minus what? Minus sine 45 degrees. And the last one is just going to be cos 45 degrees, right? So since everything is multiplying on top and the bottom, and it's a division, the negative are going to cancel out because negative divided by negative gives us a positive. So we're going to have cos 60 degrees multiplied by 10, 30 degrees divided by sine 45 degrees. And the last one is cos 45 degrees. Then now I'm going to teach you a trick or a cheating method. But this is cheating, basically. But no one's going to know if you use it the way I'm going to use it. If you punch cos 60 in your calculator, if you say cos 60, you get 1 over 2. So the rule is to write each term, the answer that you just punched. So cos 60 is going to give you 1 over 2. So you're going to write 1 over 2 just like that. Then you're going to punch 1030, which is going to give you what? Root 3 over 3. Then you're going to say this is divided by this is going to be divided by sine 45, which is root 2 over 2. Then the last one is cos 45, which is root 2 over 2. So here the goal is to never, emphasizing on the never punch this whole thing into your calculator, because they're going to see that you're cheating. You don't want them to see the fact that you're cheating. The goal is to punch each trig ratio and substitute it individually. Then, since they say without a use of a calculator, you need to simplify it like you're not using a calculator. Meaning you're gonna multiply the numerator and numerator. So if you say 1 over 2 multiplied by root 3 over 3, what's going to give you? It's going to give you, the numerator is going to be root 3 divided by 6, right? Then you're going to do that for the denominator. This is going to give you what? If you say root 2 divided by 2, multiply again by root 2 divided by 2, the denominator is going to give you a half. Then this the same thing saying root 3 divided by 6 divided by 1 over 2. And this is the same as saying root 3 divided by 6 multiplied. If you're changing the multiplication, the definition to multiplication, this one's going to go up and this one's going to go down. So this is the same as 2 over 1. What do you get? If you say 2 multiplied by, what you call this, root 3 multiplied by 2 is going to be the same as 2 root 3 divided by what? By 6. 2 divided by 6 is going to give you 3. So it's going to be root 3 divided by 3. So this will be your final answer. So this is how you would cheat. Never punch the entire thing into the calculator, because of you just suspecting yourself the fact that you cheated, and that's not cute. So now let's look at a question where we talk about co-ratios, right? Co-ratios is when we're dealing with 90 plus or 90 minus theta. So whenever you see 90 plus and 90 minus, that's a co-ratio. So let's look at the first question, right? It says cos 90 plus theta, then they give us sine theta plus 90 theta, then the last one is sine theta minus 90. So we need to simplify this question. So let's do this. So the first one, I'm going to write it on the side in red. We have cos 90 theta plus, we have 90 plus theta. With co-ratio, what happens is your sine and cos changes is trig ratio, right? Only 10 doesn't change. So let me look at this one. We need to find where 90 is what is, we need to find where there is 90 plus theta. So 90 plus theta is the second quadrant, and we see the fact that only sine is what is positive. So if sine is positive, then meaning this one needs to change into being what? A negative, because only sine is positive. But what happens when we're dealing with cos and theta? Since this one is cos, it's going to change into being sine theta. Let me explain something. When you determine the sign, whether it's going to be positive or negative, you only look at this. You do not look at what your final answer is going to be. I know the fact that it's sine theta, but since our initial was cos, and here the second quadrant only sine is positive, even if our answer is sine, this one is going to be negative because of it was a cos. It was initially a cos. That's why this is negative sine theta. So this is going to give us what? Negative sine theta, right? Let's look at the second one. We have sine theta plus 90 degrees, right? When you have it like this, always remember that your degrees needs to come first. So you need to rearrange this. When you rearrange it, you have sine 90 degrees, what? Plus theta, right? And we need to find where 90 plus theta. Where is 90 plus theta is here. Sine is positive. So since our initial is sine, this one is going to change into being cos theta. So you're going to write your answer as being cos theta. Then let's look at the denominator. We have sine theta minus 90 degrees. If we have this, remember the fact that your degrees come first, so we need to rearrange that. When we rearrange that, it's going to be what? Sine 90 degrees plus theta. Our angle or our degrees are never negative. So what you need to do, you need to get rid of the negative here. So you need to take out the negative outside. So you're going to say sine, open bracket, minus, then the signs are going to change. So this one's going to become positive and this one's going to become negative. So this is what you're going to have. Then you're going to, before using this, you're going to ignore this. You're going to only deal with the negative. If you have a trig ratio and inside the angle is negative, what's going to happen if it's sine, it's going to be negative x. This one's going to be replaced by a negative trig ratio. So this is the same as saying equals to negative sine, open bracket, 90 degrees minus theta. Right? Then now you're going to simplify it using your cos diagram. You're going to need to find 90 minus theta. Let's look at 90 minus theta. All of them are positive. So this is going to be the same as saying negative what? Since it's 90, it's going to be negative cos theta. Because of this negative affects everything. Understood? So here it's going to be what? It's going to be negative cos theta. Right? So now what we're going to do is the negative and negative divided by negative gives us a positive. So this is going to be sine theta cos theta divided by cos theta. So meaning your cos are going to cancel out. So sine theta will be your final answer. So now looking at the last question. The last question says given cos 36 is equals to P, express the following in terms of P. Then we have the first one, which is sine 54 degrees. So I'm going to write the solutions in red, right? So we have the first one as saying A is equals to sine 54 degrees, and we need to express it in terms of P, right? What do we have? We know the fact that if we say 90, right? 90 minus 36 degrees is going to give us what? 54 degrees. So you know what's going to happen is we're going to replace this 54 by this. So let's do that. If we say sine, open bracket, 90 degrees minus 36 degrees, and we use the cos diagram. If we say 90 minus theta, where is 90 minus theta is here, all of them are positive, so this is going to be positive cos. Since it's a co-ratio, it's going to be positive cos 36 degrees. And we know the fact that cos 36 is equals to P. So number A is going to be equals to P. So this will be the answer for the first one. So for the second one, we need to actually use the identity. I'm going to write the identity in blue. We know that sine squared theta plus cos squared theta is equals to 1, right? And if we take the cos to the other side, it's the same as saying sine squared theta is equals to what? To 1 minus cos squared theta, right? So we need to write this in terms of P. We see the fact that we have cos here and cos here. If we square root both sides so that this one can be a single trig ratio, so it can be like this. If we say the square root of both sides, so it's going to be sine squared theta, the square root of sine squared theta, and this whole thing is going to be 1 minus cos squared theta. This one's going to be sine theta is equals to the square root of 1 minus cos squared theta, right? From the identity. So we're going to use the identity to solve this. So this is the same as saying what? This is the same as saying sine, right? 36 degrees is equals to square root 1 minus cos squared 36 degrees, right? Then now we know the fact that what? Cos 36 is equals to what? Is equals to P. So this is the same as 2 P's. So we're going to say sine 36 is equals to square root of what? Let's change this one. If we say 1 minus open bracket cos 36 degrees all squared, we're going to replace the cos 36 by P. So it's going to be sine 36 degrees is equals to the square root of what? Of 1 minus P squared. and this will be your final answer. So for number C, we have 126 degrees. First, we need to change it into an identity so that it contains cos and sine. Since we have cos, right, we know that cos is p, and sine we already solved it as square root of 1 minus p squared. So we're going to change this. This is going to be the same as saying sine 126 degrees divided by cos, right, 126 degrees. If we say 90 plus 36, it's going to give us 126 degrees. So we're going to replace this 126 by 90 plus. So we're going to say sine, here it's going to be 90 plus 36, sorry, and divided by cos 90 plus 36 degrees. Then you're going to check on your cos diagram what's 90 plus. 90 plus is the second quadrant, and it's going to be sign is positive, right, and the rest are negative. So this one is going to remain as being cos 36 degrees, and the denominator is going to be minus sine 36 degrees, right? So we know the fact that cos 36 is equals to p, and 90 is going to be minus square root of 1 minus p squared, and this will be your final answer. So now let's look at the last one, which is cos 324. If you say 360, right, plus 36 degrees, it's going to give you what? It's going to give you 324 degrees. So you're going to replace the 324 by this. So you're going to say cos 360 degrees plus 36 degrees, right? Then you're going to find where is 360 plus theta. 360 plus theta is here, so everything is positive. So you're going to say cos 36 degrees. And we know that cos 36 degrees is equals to p, and this will be your final answer. So now I want to talk about the important information, right? That's going to really help you when solving any reduction question. If we're dealing with 180 plus, 180 minus, 360 plus, and 360 minus, we look at the trig ratio, we look at the cos diagram, and we just look at where is it negative and where is it positive on its respective trig ratio, right? The one that becomes tricky is when we have cos 90 degrees plus theta, or sine 90 plus theta, or sine 90 degrees minus theta, then cos 90 minus theta. Let me add 10. So it's going to be 10 90 plus theta, and 10 90 minus theta. So this one is where things changes, which is our core ratios, right? If we have 90 plus or 90 minus, the sign changes into cos, and the sign changes to cos, and the cos changes into sine. So this one is the second quadrant. So sine is sine is going to be the only one that's positive. So the first one is going to be minus sine theta. The second one is going to be positive cos theta. And the last one is going to just remain the same as being as being minus 10 theta. Then here it's going to be 90. Everything is positive. So this is going to be cos theta sine theta. And the last one is going to be 10 theta. So remark, 10 remains the way it remains the same, only cos and sine changes. Another important thing is when we're dealing with negatives. If we have sine minus theta, and we have cos minus theta, and the last one is 10 minus theta, right? What's going to happen is this one is going to be it's going to be negative. So it's going to be negative sine theta. This one's going to be positive. Only cos becomes positive. So this is going to be positive cos theta, and the last one is going to be negative 10 theta. So this is the final remarks I wanted to discuss about